This diagram shows 4 regular hexagons. Shade in 1/3 of the diagram. So the word regular tells us that all of the sides of the hexagons are the same length. Now we need to shade 1/3, but our hexagons haven't been divided or split into equal parts, because these parts at the top and bottom are twice as large as these parts at the side. So what we can do is draw a line down the middle of each hexagon so that we have a shape that's divided into equal parts. And we have 6, 12, 18, 24 parts altogether. So we need to think 1/3 is the same as what over 24. So we need to find an equivalent fraction, because the numerator will tell us how many of the 24 parts we need to shade. Now 3 times 8 is 24 and 1 times 8 is 8. So we need to shade 8 of these parts. So we can shade any 8 parts, but if we shade these parts here, that will be 1/3, because we have 8 out of our 24 parts shaded, and that's equivalent to 1/3. Write in the missing numbers. So we have 438 divided by 8. 43 divided by 8 is 5, remainder 3, because 5 times 8 is 40, plus 3 is 43. So now we have 38 divided by 8. So because we're going to get a remainder, we can extend our dividend with a decimal point and then zeros. So 38 divided by 8 is 4, remainder 6. 60 divided by 8 is 7, remainder 4. And then 40 divided by 8 is 5. So our missing digits are 5 and 7. Here is an equilateral triangle inside a rectangle. Calculate the value of angle X. So the word equilateral tells us not just that all of the sides of the triangle are the same length, but also all of the angles are the same size. And equilateral triangles have angles of 60 degrees. That's because we always have 180 degrees in a triangle, and if they're all the same size, because we have 3 angles, we can divide 180 by 3 to get 60. So we know that the angles in our triangle are 60 degrees. Now the corners of a rectangle, and we're told that it's a rectangle, are right angles, and right angles are 90-degree angles. So we have this angle here of 12 degrees, this angle inside the triangle of 60 degrees, and we need to think how many more do we need to make 90 degrees. Well, 12 and 60 makes 72, and if we subtract 72 from 90, we get 18. So angle X is 18 degrees. Rectangle ABCD has a perimeter of 24 centimetres. Sides AB and DC are twice as long as sides AD and BC. Calculate the length of side AD. So we need to work out this length here from A to D. And we know that the perimeter, so the total distance around the outside of the rectangle, is 24 centimetres. So with a bar model, we can draw one square to represent AD, and then another square to represent line BC. Now line AB is twice as long as lines AD or BC, so we can have 2 squares to represent AB and also 2 squares to represent line DC. Now we know that the perimeter is 24 centimetres, so all of our squares together have a total of 24. And because we have 6 squares, we can divide 24 by 6, and that tells us that we have 4 centimetres in each square. So for side AD, that's 4 centimetres. Side BC will be 4 centimetres as well, but then lines AB and DC will both be 8 centimetres because they have two squares of 4 and 2 times 4 is 8. So 8 is twice as long as 4. The diagram shows a rectangle. Calculate angles X and Y. So to answer this question, we need to remember that angles in a triangle add up to 180 degrees. And we also need to spot that if you have lines, diagonal lines across a rectangle, you create isosceles triangles. So isosceles triangles have two equal angles. So this angle here will be the same size as this angle here, because this side length of the triangle is the same as this length here. So our triangle is isosceles. So because this angle is 36, this will be 36 as well. So that's 72 altogether. And if we subtract 72 from 180, we get 108. So this angle here is 108 degrees. Now vertically opposite angles are the same size, and you get vertically opposite angles when straight lines cross. So the opposite angles are the same, which means that angle X will be 108 degrees. Now we can also remember that Z angles are the same size. So we have Z angles because we have a rectangle, so we know that this line at the bottom will be parallel to this line at the top. And when you have a line joining or crossing parallel lines, the angles inside the Z will be the same size. So because this angle here is 36, this angle will be 36 as well. And then to find angle Y, we just need to remember that angles on a right angle add up to 90 degrees. And we have a right angle because the diagram shows a rectangle, and a rectangle has right angles in its corners. So we need to think 36 plus what is 90? Well, 90 minus 36 is 54, so that means that angle Y is 54 degrees. Circle the largest number. Now that's 5,555,055. We can see that this number will be the smallest number because it only has 6 digits, and all of our other numbers have 7 digits. And if we're comparing whole numbers, a number with fewer digits will always be smaller. So this number here doesn't have a millions digit. All of our other numbers have 5 as the millions digit, but if we go across to the hundred thousands, here we have 0, here we have 5, and here we have 0. So this number with 5 in the hundred thousands will be our largest number. Every 100 grams of brown bread contains 6 grams of fibre. A loaf of bread weighs 800 grams and has 20 equal slices. How much fibre is there in one slice? So we know that for 100 grams of bread, we have 6 grams of fibre. A loaf of bread is 800 grams, so that's 100 times 8, and 6 grams times 8 is 48. So there are 48 grams in the whole loaf of 20 slices, but we want to know how much fibre is there in one slice. So we need to divide 48 by 20. 48 divided by 20 is 2 remainder 8, because 2 times 20 is 40, and then we need 8 more to get 48. So we need to extend with a 0.0, copy up our decimal point, and then we can write our remainder 8 in front of our 10th digit. And now 80 divided by 20 is 4, because 4 times 20 is 80, so that's 2.4 grams of fibre in one slice. calculate the area of this parallelogram. So to find the area of a parallelogram, we multiply the base by the height. So the base we can see is 12 centimetres, and then the height is 4 centimetres, and 12 times 4 is 48. So the area is 48 centimetres squared. And it's important that for the height, we use the distance from bottom to top. So we need to use 4 centimetres, not 6 centimetres. 6 centimetres is just the length of one of the sides, but that's not the same as the height. The length that's the height will be perpendicular, so crossing at right angles with the base. Cleo has 24 centimetre cubes. She uses all 24 cubes to make a cuboid with dimensions 6 centimetres, 2 centimetres and 2 centimetres. So dimensions just means the size of the edges. So this edge is 2 centimetres, this edge here is 2 centimetres, and this edge here is 6 centimetres. So that's a cuboid that you can make with 24 cubes, because 6 times 2 is 12, times 2 is 24. So the volume of this cuboid is 24 centimetres cubed. Now we want to write the dimensions of a different cuboid she can make using all 24 cubes. So we need to think what times what is 24. Well, we could have 4 times 3 to make 12 times 2 is 24. We could have 12 times 2 times 1. We could have 24 times 1 times 1. We could have dimensions of 8, 3 and 1. Or we could have a 6 by 4 by 1 cuboid. A shop sells rolls of wire. 2 rolls, A and B, each have 45 metres of wire on them. The wire on roll A is cut into 1.25 metre lengths. The wire on roll B is cut into 2.25 metre lengths. How many more lengths of wire are cut from roll A than roll B? So let's take roll A first. We know that one length is 1.25 metres and the total length is 45 metres. So we need to divide 45 by 1.25, and the easiest way to do that is to count up in steps of 1.25 until we get to 45. So if one length is 1.25, 2 lengths will be 1.25 times 2, so that's 2.5. Then we can double again to get 4 lengths, and double 2.5 is 5. And then if we know that 5 metres makes 4 lengths, we can calculate how many lengths we get from 45 metres, because 5 times 9 is 45. So 4 times 9 is 36. So we know that we can get 36 lengths from roll A. So now let's look at roll B. We know that one length is 2.25. So again, we can count up in steps until we get to 45. 2 lengths will be 2.25 times 2, or 2.25 plus 2.25. So that's 4.5. And then we can calculate 4 lengths. That will be 4.5 times 2, so 9. And then if we know that 4 lengths is 9 metres, 9 times 5 is 45, and 4 times 5 is 20. So from roll B, we can get 20 lengths. We might have been able to do the jump straight away. So if we know 2 lengths is 4.5, 4.5 times 10 will be 45, 2 times 10 is 20. So the question asks how many more lengths of wire are cut from roll A than roll B. So we need to find the difference, so we use subtraction, and 36 minus 20 is 16. So our answer is 16 lengths. A circle has a diameter of 22 centimetres. what is the length of its radius? Well, if we have a circle, the diameter is the distance from one edge to the opposite edge, or the edge on the opposite side. So it's a line that goes through the middle of a circle, connecting the two edges. Now the radius connects the centre of the circle to the edge. So the radius is always half the length of the diameter. So we can find half of the diameter, half of 22, by dividing by 2, and that tells us that the radius is 11 centimetres, because the radius is half of the diameter. And though I've drawn the diameter as a horizontal line and the radius as a vertical line, the diameter can in fact be anywhere. It doesn't have to be horizontal, it just has to be a line that connects two edges and goes through the centre. And same for the radius, that doesn't have to be vertical like I've drawn, it could join any point on the edge of the circle to the centre of the circle.